Naive RAG, embed a query, search a vector database, stuff results into a prompt, works surprisingly well. Until someone asks a multi-hop question like compare our Q3 pricing strategy to Q2, and it completely falls apart. Today I'll show you 5 strategies that fix these failures. Let's start with why naive RAG fails. It works great for single-topic queries with direct matches. But it breaks on multi-aspect queries, questions where the wording doesn't match the document's language, and cases where small chunks lose critical context. Strategy 1. Multi-query retrieval. The idea is simple. A single query embedding might miss important aspects. So you use an LLM to generate 3 reformulations of the original query, search with each one, and merge the results. Why does this work? Your original query, compare Q3 to Q2 pricing, might miss Q2 specific chunks. But a variation like Q2 versus Q3 pricing changes catches them. One extra LLM call gives you 20 to 30% better recall. That's the easiest upgrade you can make. Strategy 2. DE hypothetical document embeddings. Here's the core insight. Your query is a question, but your documents contain statements. They live in completely different linguistic spaces, so their embeddings might not be close to each other. The fix: ask the LLM to generate a hypothetical answer first, even if it's not perfect. Then embed that hypothetical document instead of the query. Now you're searching document to document, and the embeddings land much closer together. Strategy 3. Parent-child chunks. This solves a classic trade-off. Small chunks give precise search results but lack context. Large chunks have context but dilute the embedding. So why not use both? You index small child chunks for search precision, but when you get a hit, you return the larger parent chunk for context. The code creates parent chunks at 1,000 tokens and splits each parent into 200 token children. Search on children, return parents. 0 extra runtime cost, much better context. Strategy 4. Contextual retrieval. This is Anthropic's method. The problem: a chunk like the company reported 4.2 million revenue, up 23% year over year, is useless without knowing which company and which quarter. The solution: before embedding, you use an LLM to prepend context from the full document to each chunk. So that chunk becomes, from Acme Corp's 2024 Q3 earnings report. The company reported 4.2 million revenue. Anthropic found this reduces retrieval failures by 49%. Strategy 5. Sentence window retrieval. You index individual sentences for maximum search precision, but when you find a match, you return a window of surrounding sentences for context. Think of it like using a highlighter, but with a magnifying glass. Now here's the real power move: combining strategies. The best production RAG systems use multi-query generation, then hybrid search with both vector and BM25, merge and deduplicate candidates, re-rank with a cross-encoder, and expand with parent chunks. But don't over-engineer it. Start with naive RAG. It handles 60 to 70% of queries. Then measure what fails and add the strategy that fixes your specific failure mode. Multi-query is the easiest upgrade. Parent-child chunks give the best bang for your buck, and contextual retrieval is worth the ingestion cost. That's 5 battle-tested strategies to take your RAG pipeline from good to great. In the next episode, we'll tackle context stuffing, because retrieving the right chunks is only half the battle. You still need the LLM to actually use them. Subscribe so you don't miss it.